you want me to take it over?
Sorry, I didn't get that.
Do you want me to take over now?
Oh yeah, sure. You can just take over. The stage is
All right.
yours. Yes.
Thanks for that beautiful intro. Yeah. So Joyce mentioned that I'm a founder. I'm actually a co-founder of Data Projects. So it's a company that I started with two of my two former co-founders from Ashanti AI. So in 2019, we had started our own company. We worked at a company for about 3 years, and then we went separate ways. We left the company with somebody else, and then eventually the company was sold. So about a year ago, we got back together and said that, hey, AI has been taken off at an insane speed, and we would like to start a 2.0 of our old company, if you will, um, solely because that there was a market demand for what we used to provide. Some of our old clients did reach out to us to say, hey guys, if you're thinking about starting a company again, we are looking for those particular skills. So we went ahead and started a second company. I have a full-time job. I work for a mining company as an integrated risk management data scientist. So on a day-to-day basis, we analyze large sums of data from like 9 mines that are operating in South Africa and Zimbabwe. And also, on weekends, we get together, we come up with projects, we see what clients are looking for on our startup, and then we provide those particular services to them. So today, what I'll be sharing with you guys, and I hope that it'll add value, because it appears last year's shares add value because our colleagues over there called me back to this year's to contribute um, with more details than I did on the last session. So I'm going to be sharing my presentation from Google Colabs. It has disconnected my runtime, so I don't think I'll be able to run some of the cells. But what I'll be sharing about, just a quick outline. It's just I'll be touching on, the possible career path you could follow if you follow data science as your learning path. What job opportunities should you look forward to? What skills and statistics are currently saying in terms of the demand from the market with the training that you're currently embarking on. And then I'll be touching just a little bit on the Python fundamentals. On top of that, we'll be talking data structures. And then after data structures, we'll be looking at real world applications. So I do have use cases that I put together that in my capacity I've worked on. It's just that the data that I'll be sharing with you on the real world applications would be, data that I generated myself, just so that you can have an idea of, the possible scope of projects that you can take on as a data scientist. And not just only as a data scientist, as a Python programmer as well, because Python programmers, you'll see from my share over here, they do earn quite a bit of money. A modern data scientist, I'll share. All right, so that's me. I shared with the table of contents. So just a brief overview of why Python is important, particularly in the African perspective. We often, talk about America this and America that, and granted, they do have presented themselves as a leader in the space, but I think also Africans, we do need to develop these particular skills so that we can solve African relevant problems, because they may not appreciate, the intricacies of the problems that we face in Africa. So that's why we need to capacitate ourselves and future generations to make sure that we always have skills ready to tackle the problems that we currently are facing. So yeah, one of the fastest growing careers fields in Africa, it is technological advancements. There's a lot of money that has been set aside to be developed, to be invested in the tech space in Africa. So I will share this notebook with Joanne and you guys will get access to it. You can click on some of the sources on the articles that I've written here. It will take you and then you'll be able to appreciate the full article if you want to do that. But yeah, just understand that there's a lot of money that has been set aside to make sure that Africa is capacitated by various investment houses. Now let's look at the job growth statistics, right? So this in Nigeria, by 2030, it is estimated that 28 million tech-related jobs will be created. In Kenya, 17 million tech-related jobs will be created by 2030. In South Africa, it has been steadily growing. I was looking for the stats for South Africa, but I couldn't find it. The only ones I found in South Africa was how much Python developers earn, and they do earn quite a bit of money. So entry level, you earn about 360,000 rands per annum as a Python developer, right? You're not a data scientist, just as a Python developer. When I started working as an intern data scientist, I didn't even earn 30% of that amount. But as an entry level Python developer, you earn quite a bit of money, and you could see what experienced senior Python developers earn. That is a lottery ticket that they get as a salary. It's 9 million annually, so that's a lot of money. So right, like I said earlier on, that Python and basically the skills that I'm talking about today, tech skills, you have the ability to impact diverse industries. So you're not limited to say that you're a Python developer, you're a data scientist. Now you're doomed to work in the mining industry like myself. No, you can venture into fintech, you can venture into healthcare, you can venture into automation, you can venture into one of my friends that I started the company with. He works for an organization that works for the government, and they have large sums of data that they're processing on a daily basis. So you have endless possibilities on which industries you might be able to find employment in and eventually impact with your data skills. All right, so the third portion here is just looking at specifically data science, AI, and cybersecurity. You can see I've listed relevant remuneration that you can expect to earn. Colleagues, you'll forgive me for listing the currencies in South African rands. I know we come from different countries in Africa, so you will convert to your local currency. But just know that 1 million rands per annum, it's a decent living wage. And in data science, so the interest and the demands of these skills, they have been constantly rising since 2010, since the rebranding of statistics as data science has been introduced in the industry. Year on year, we've had an increase in the demand for the skills. And I can attest to this because I went to Explore Data Science Academy in 2018. So I did a 1-year program. And then 2019, like I said, we started our own company. So this is from a 1-year program that we did. We did Python, we did SQL, we did Power BI, and then we did other communication skills like PowerPoint presentations and all those things. And we were able to start our own company that was very successful. I'll say this is from people who did a 1-year program in data science that we got together and we started a business. We were able to get high level clients to come in and be clients for our new startup. So the skills for data scientists are in demand. And at that point in time in South Africa, there weren't a lot of people who had formal training in data science. So that's why we were able to take advantage of, that first movers advantage. So yeah, it has been steadily rising, 71% year on year. And now in AI, I'm sure you've heard recently DeepSeek does, ChatGPT this and that. So every month there's a new ChatGPT. A large language model that is breaking all these boundaries that's coming. That's AI, and those models, their instructions, like when you type a prompt into like, hey, can you give me the data that that's going to process your prompt in Python and formats the output in Python. So Python is very instrumental in large language models. Yeah, the meeting has been recorded, Chidima. All right. So yeah, I think I've shared quite a bit about what you can look forward to in terms of like, the potentials for employment in the industry as a data scientist. Um, so yeah, towards the end, I'll be talking about data science and machine learning. Just you can see some of the use cases that you can do. I've coded everything inside this notebook, so you should be able to run the query. I said still reconnecting to the runtime over there, even though I restarted the session. So this means I won't be able to run the cells so that you can see the outputs of the code. So now the second section of this session, I'll be talking about fundamentals of Python. Python, just like all other programming languages, there's got like set rules in which you can communicate um, with Python to give it specific instructions so that it can run the instructions as you provided it and give you the desired outputs that you want. So the most important and fundamental topic that you need to understand before you start coding in Python is your data types. So data types, it's just tells you the way the format of information that you're going to be inputting into Python. So different data types have got like different capabilities that you can be able to apply. So we have these four that are already inbuilt inside Python. The first one is an integer. So integers are just your whole numbers, 0, 1, 2, 3, all the way to infinity, and then you have floats, right? So floats, normal English, we just call them decimal numbers, but in Python they're referred to as floats. You can see after the 3, there's a 0.14. This is the value of pi, but it's a float in Python. And then we have this one called a string. So this is just text, right? So you would see when I run the data, hopefully by the time the runtime will be connected, sometimes strings are called objects. And then integers are called int64, so that's a 64-bit. And then you have what is called booleans, right? Booleans is just true or false. Like you can ask it if 1 is greater than 2, and then it's going to say that's false because 2 is greater than 1, not the other way around. So this part of the section is how it's supposed to run this code. I hope it does run. Just to give you an example of data types that you find in Python. So the age is a whole number. You can be 25 years old. If you want to be very technical, we could add the decimal points as the months, but normally you present your age as 25. The price of goods is 99.9 and something. And then the name Alice is a string or an object, like I said. And then is Alice a student? You can see it's false. That's a Boolean over there. So I see that the cell is taking a while to run, but you can see from the early output over here, the first integer. So when you assign the age variable to the integer 25, you can call the type of integer over here, and then you ask Python to print it out, and then it's going to tell you that your first variable that you assign is an integer, the second one is a float, the third one is a string or object, and then you have a Boolean over here. So are we happy with the data types, and then I can move on to variable assignments?
Sorry, Kenneth. Do you mind zooming in on your screen so that we can see clearly what? Yes, I think that's better.
That's better. Okay.
Thank you very much.
All right. Yeah, it seems the notebook is not. It doesn't want to run. So let me just do this in the meantime. I want to run the second session. Hopefully this one connects to the runtime, because when we get to the real world applications, I'm going to need to run the code just so that you could see some of the nice work that you can build in Python. All right, that one is also still connecting. It's fine. I'll just move on to the variable assignments. So variable assignments is just you declaring a variable. By declaring a variable, you say that I want message to hold this string or the object. So now your message is going to be whatever text you assign here. And you can see that I've used two quotation marks around the string, just so that Python can understand that this is not a number, this is not a Boolean or a float, a text. So you assign it with those double quotation. You could use single quotations, but now the problem with single quotations is that if, say, you want to say the message you want to assign to this variable over here, he's back, and his back has got a single quotation inside. Python is just going to read the first two as the text, and then it's going to spit out an error for this one. It's going to spit out an error for this one. That's why oftentimes you'll see that we are using double quotations so that we can include the single quotations if the text has a single quotation. All right, you see it's determined that it's not going to be able to run. But in any case, this is what the variable assignment looks like in Python. You just tell it that, hey, here's a message, and I want you to hold the text inside the message. And you could also assign a number, say that the message maybe is a 5. If you print here, it's going to say 5 over here. And if you say is message greater than 10, it's going to tell you that Boolean false, because message was already assigned 5, and 5 is not greater than 10. That's some of the stuff that I wanted to demonstrate, but I see Google decided that they were going to restrict my capabilities today. All right, so the second section, if we're happy with the variable assignment. So I'm going to keep building on the previous knowledge. So the previous knowledge was the data types. And then from data types, we go to variable assignments. And after variable assignments, you're going to go to operators, right? So you can see now I've assigned 2 integers to 2 variables, variable A and B. I said A is equals to 10 and B is equals to 3. So this is just to demonstrate our operators. So we've got 3 different operators that we can use in Python. The first one is an arithmetic operator. So these ones are very intuitive. This is a plus. You could say A plus B. It's going to give you 13 because that's 10 plus 3. You could use A minus. A minus 3. A minus B is going to give you a 7. And then we have this symbol over here. So this symbol we use it to indicate divide. So if you say 10 divided by 3, you're going to get 3.33. And then we have this asterisk. So the asterisk, we use it to signify multiplication. So if you say A multiplied by B over here, you will get 30. Oh yeah, the outputs are over here. You will get 30. And then we have the modular function. This one is very important. So it's kind of confusing, but if you really think about it, it's not. So it gives you the reminder of the divider, right? So if you say 10, this percent side 3, you're going to get a 0.33. So the reminder is 0.33. So if you say for example, our B was equals to a 2, right? We divide 10 by 2 by saying A percent sign 2 is going to give us a 0. Why does it give us a 0? Because 5 divided by 2 is just 5. There's nothing, there's no decimal point after the 5. You'll see in one of the exercises why I implement this just to demonstrate the difference between the modular sign and the division sign, right? And we also have comparison operators. So this one you've seen. This one we're saying A is equals to B. So that one is very intuitive. If you say double equals, so then we would imply that A and B are similar. What do I mean by that? If we say, how do I have it here? All right, so we know that A is a 10 and B is 3, right? When we run this cell, we ask it, is A greater than B? It says true because A is a 10 and B is a 3. And then now we say, is A equals to or similar to B? Right, and then we get a Boolean that says false because A is a 10 and B is a 3, so they're not the same. If A was 10 and then B was 10, it was going to return true over here. So now we also have logical operators, right? Like I've said that logical operators are very intuitive. This is a greater than sign. This is a less than sign. So if you print A is greater than 5, it's going to give us true. Actually, both of these statements have to be true because we have an AND over here. So A is greater than 5, that's a 10, and B is less than 5, which is a 3. So this means it's both of these conditions are true, and then we get that true result over here. Right. Now we can say not A is greater than 5, which is actually, this one is true because our A is 10, but now we're saying not, we make it a double negative, and therefore it makes the statement false. It would be nice if I could run this out so that you can see what I mean when I say that. But you will have access to the notebook, and then you can run it. You can actually download, run this notebook with Jupyter Notebooks because you don't need internet connection for that one. So the last aspect, okay, we're done with the operators. So now we're going to go to the control structures, which is where it starts to get a bit complicated, but it's also very intuitive, right? So we have our control structures over here. We have if, we have elif, and we have else. So elif stands for else if. So it's like if you have a first if statement and you also want to have a second statement, you add else. I'm sorry, I'm not sure whether that was a question. Okay, guys, if that's not a question, I'm gonna demonstrate the example of control structures. So I'm gonna start by assigning a variable named x to 10. So I say x is equals to 10. So now I'm gonna run the first if statement. Right? Let's just focus on those two lines of code. I ask Python to print positive number if x is greater than 0. I've already assigned x to be a 10, and we know that 10 is greater than 0. So it's going to print a positive number because the statement is true. If the statement was not true, it was going to run to the second one to say, elif is x less than 0. And then we know x is not less than 0 because it's a 10. And then if these two conditions are not met, and then you can print the else statement, which is a 0. But because this one was true, it printed out the first statement that was true. So you'll see how we demonstrate this in a code down the line. And then you have for loops. Actually, you have loops for and while. So what loops do is they help you execute these control structures in a repetitive manner. So there's two different types. There's a for loop and then there's a while loop. So you use the for loop if you know your range, or if you know, if you have a list of items that you want to iterate over, and then use a for loop, right? If you do not know, if you don't have a range or a list, a task of things that you want to iterate over, you want the loop to keep executing whatever code it is you want it to execute while a certain condition is true, you use a while loop. Let me just demonstrate this one here. So the first line of code here, what it's simply saying is Python over a range of 5. So Python counts from 0. So 0 is going to be a 1. And then because we put 5 over here, it's not going to count all the way to 5. It's going to count to n minus 1, which is a 5, minus 1, which is a 4. So it's going to count 0, 1, 2, 3, 4. So we're saying over this range, I want you to print iteration, this string. Remember, we spoke about the string and objects in a session at the top there. And then I want you to print I for whatever I is at that point when you run it, right? So we'll say for I in the range of 5, the first I is going to be a 0. So what is Python going to do? It's going to print iteration, semicolon, and then 0 over here, which is the first iteration over here. Now it goes to the second item, which is a 1. It's going to print iteration, same statement, and then I, which at that point, I is 1, all the way to 4. Like I said, when you put a range over here, Python will print all the way to n minus 1, which is about 5, and then that's a 4. So we know we have 5 items in the range. which is 0 all the way to 5. Therefore, we use a for loop. But now, in a different application where we want Python to keep printing as long as our condition is met, we use a while loop. So now we assign count to 0, create a variable, and then we assign it 0. I see it saving there, but it doesn't want to run my code. Okay, so we say count is equals to 0, and then we say, hey Python, while count is less than 3, and we know our count is 0, can you print count is, and then the number of that count at that point of the run? So the first run is going to be 0, and then it's going to print that. So now there's this new addition that we've added to our for loop to say that once you've done printing count is and whatever the number is at that count, I want to. So normally that's shorthand, but normally you would write this line of code like this. You would say count is equals to count plus 1, and we know count is 0. So this is count now is going to be 0 plus 1, which is a 1. And then Python is going to run this again. Now our count is 1. 1 is less than 3. Now print count is n1. And then we get this one over here. Then it's going to run again. Now count is no longer 0, it's 1. So it's going to come here and say count is 1 plus 1. And then it's going to be 2. 2 is still less than 3. Right? And then it's going to run. Now it's going to go again. Now we have a 2 over here. And I will say count is equals to 2 plus 1, which is a 3. When we get here, the while loop is going to read the count as a 3 and say, using my logic operator, 3 is not less than 3. 3 is equals to 3. And then it's going to terminate the for loop. Then it's going to stop running with it. So this is shorthand for writing exactly what I wrote. Count is equals to count plus 1. You see a lot of these funny formats as you develop in Python coding. Are we still following up until this point before I go over to functions? Any questions? Any point of clarity that we want? All right, I'm seeing a lot of thumbs up. And I'm going to head over to functions now. So now what functions do? I think I do have a message. There's one person who raised their hand. Can you just unmute and ask a question? Oh, are you happy now? Guys, if you don't want to unmute and ask a question, you can just type the question in the chat, and then I'll be able to read it out for the class, and then I'll provide you with the response. Happiness? Oh yeah, I see the founder wanted the link to the notebook. Yes, you will get access to the notebook after the session. I just wanted us to focus on it and not run the code. Let's just look at what the content is on the notebook, and then you'll run it after that. Rovimbo,
Rovimbo, your hand was raised. Okay, probably raised it by mistake. So I think you can just go ahead and continue.
I think Rovimbo is shy. If he's shy, can you just type the question in the chat?
Rovimbo, don't be shy. Please speak up.
No, man,
or you can just type your question in the chat box so I can read it out.
Awesome. All right, so let me continue now. So we'll be talking about functions. So what functions do is instead of writing this code that for I in a range of this, print this, sometimes this is useful, but when you're building like long applications, like long data analytics scripts, this becomes very inefficient, very fast, particularly if you work with a large data set. So now what you want to do is to modularize your code. And how do we do that? We use functions, right? So this is, whenever you see this blue color when you're writing Python code, just understand that it's an inbuilt function. So right, this one, these 3 letters, what you do is you're telling Python that right now I'm actually building a function. And you start by saying def. Always when you build a function, you start by saying def, followed by whatever the name of that particular function you're building is. So this one is not standard. You can name it greet, you can name it check, even odd number like I've done here. And then over here, this is what is called a variable, right? What your function is going to be accepting as an input and then running a computations over there, right? So right now we're building a function to greet people. It's going to take the variable called name, and then it's going to return hello. This is going to be standard, and whatever the name you supplied is over here. And for example, I've ran this function greet Alice, and then it says hello Alice over here. Right? You see the output looks exactly with the same format that we put over here. So your functions will always have a return function, a return statement rather. It's going to be pink in color, and then the output I was saying, the hello, it's standard, is a string, and then comma, and then we use this F formatting to say that whatever name is supplied, combine it with the string, add an exclamation mark, and then print that out. So this is, you will not get a simpler function than this. You guys are obviously going to build more complicated functions because you're all smart people. So this is another simple function that I built. So what we want to do here is we want to check if a number that we supply, like I said, start by telling Python that, hey, I'm about to build a function. You say def is going to turn blue, and then you say the name of your function. So the name of my function is, I want to take a number as an input from the user, and then run my calculations, and then determine whether that number is odd or even, right? And so I'm going to take that input over here, and then you put your semicolons, because if you don't put the semicolons over here, your function is not going to be able to work. Most programming languages, they use semicolons, and it becomes a mess. Python uses a lot of indentations. So after you write your, you declare your function, you write the name, you write the variable. Variables can be more than one, by the way. It doesn't have to be one. And then you write your semicolons, and you hit enter. It's going to automatically auto indent it, and then you can put whatever computation you want. So what we are saying here is that we will take a number, and then with this number, we'll check if the modulo of this number by 2 is equals to 0. What do we mean by this? If you divide this number by 2, do you get a whole number or do you get a number with a float? If we get 0, meaning that we get 5 divided by, 10 divided by 2, we get 5, and then we know it's an even number. If it's not equals to 0, then we know it's an odd number. Say 5 divided by 2 is going to be 2.5. So the modular here is going to be 0.5. It's not going to be a 0. Because there's no reminder when you divide 10 by 2, but there's a reminder of 0.5 when you divide 5 by 2. Right? And we want our function to tell us even and odd, simple as that. Yeah, so I don't think this test is going to run. But what I did here is I also added something new. So we started by declaring a variable called num. And we want to force this number to be an integer because we want to divide integers over here, right? So if I add 1.9, it's going to convert 1.9 into an integer and make it a 2, right? And then this input statement here, if you run this cell, it's going to prompt you to add a number, and then you enter your number. It's going to tell you enter a number, and then you enter a number, and then it's going to run this function called check even odd, and then it's going to divide by 2, well, module by 2, and then if you get 0, then it's an even. If you get any number besides 0, then it's an odd number, right? So this is a nice way of implementing all the concepts that we've touched under data structures. Right, so I see the code is still not running. So I think right now we can move on to our session number 3. If there are no questions or anything that I need to clarify, let me just check the chat real quick. All right, so no questions on the chat, no hands. This means that everybody's following along, correct? Go for it, Tshepo.
Hi, so thank you very much for this wonderful opportunity. So I wanted for you to elaborate on the LF.
Oh, on the elif statement.
Yes, please.
So elif stands for else if. So if our first condition is met, can we check the second condition? If the second condition is met, then write return a zero to let us know both our conditions are not met. So let me create a different example. Um, right. Let's create a declaring a variable called gender. I need to put it inside double quotations so that Python knows that that is a string. Um, yeah, that's AI, by the way. You can see it's auto coding. So what I want to do here is say if gender is equals to male, if gender is equals to male, return man, right? So I want you to bear with me. I'm about to make a controversial statement, but I want to demonstrate this point, right? Please don't cancel me, right? So in this variable that I've declared, I said gender is male, right? And then you provide the input male, and then it's going to look through if gender is equals to male, it's going to return man, right? So the elif statement is if you have a second condition that you want to check, right? If you don't have a second condition, like in this particular use case, I don't have a second condition. I just want to know whether this person is a man or a woman. And if provided male, so I know it's men, right? So now, because um, the the first condition has been met to be man, I can say now return woman. Um, so you see, like if you have two conditions, it's either this one, if that, or else this one. If you have more than two conditions, like five, the first one is going to be if gender is equals to male, then return man. Then you say else if gender is equals to non-binary, return non-binary. If gender is equals to that other L is L if the other one, and then you keep adding that. But these two will always be standard. You always have the first one and the last one. The first one is if, the last one is else. Else if comes in between these two if you have more than one, more than two conditions. I hope that clarifies it a bit.
Yes, thank you.
All right. We have a second question. You can unmute and then give us a question. Oh, Ravimba said that he wanted to see if I
Oh,
can.
sorry, sorry. Uh,
Yeah.
sorry. Can you get me? I was just asking if you can expound on the functions, the built-in, the inbuilt functions, and uh, uh, the defined functions. How would we call them? The
So
functions that
now,
you define them yourself and the inbuilt functions.
so I'm not sure I
Yeah,
follow. You said
just a difference on them.
you want to understand the difference between inbuilt functions.
Yep. And then the
Okay,
other,
so
the defined human defined.
All right, so if I understood you correctly, you wanted to understand the difference between inbuilt functions. I'm not sure what the other one was, um, but with inbuilt functions, there's actually quite a lot. There's a lot of cheat sheets out there that can show you the functions that are already been built so that you can just utilize them. If my code was running, I was actually going to demonstrate that to you. But let me just add a second code of here. Let's say I want to test with this 1, 2. So I've created this list. I know I haven't touched on lists, but it'll help demonstrate what I want to say. So you could say sum of test. You can see sum has got like a color formatting already. So what this will do is it'll add 1 and 3. So these are already inbuilt Python functions. I can share some cheat sheets with you guys that I've had. So there's actually quite a lot we could use. Actually, it's not average. I'm not sure if this is going to work, but no, so that one is not going to work if I call it in front of that list. So I would have to call it and then wrap the list with it. So mean is to calculate the average of this two. It's just going to say 1 plus 3 is a 4 divided by 2. The output here is going to be a 2. The output here is going to be a 4. So there's a lot of already functions that are inbuilt inside Python. So what I was showing you guys over here is if you want to build your own bespoke functions, because there's going to be circumstances where you need to build a function that does a lot of things, and then you could add all the functionality underneath the function, or you could build multiple functions. And I didn't include this as part of the lesson, but you could build multiple functions and you put them inside a class, and then you call the class and the function as a method. Like grid would be a method, even odd will be a method. I hope that I've answered your question over there. Can I get a thumbs up if you're happy with my response? Guys, can you still hear me?
Yeah.
Okay. All right. Third section of our conversation, let's talk about data structures and popular Python libraries. So these are the libraries that I've picked are the ones that are relevant to your course of study. So there's the thumbs up are popping up now. I think my internet was acting up over there, but I'm glad that we're all back on track right now. So now we'll be talking about data structures. This is actually the very important section of your study. You need to understand this one because most of the time this is how we'll be interacting with the data. We do have about 4 data structures that I've included here. There's actually more than this. I sort of added a data frame. I think that's the one you work with the most, but you'll see when I talk about the most popular Python libraries. Pandas, which is a data manipulation library, we'll be dealing a lot with data frames over there. So the first one we have is a list. So a list is exactly what you think it is. It's just a variable declared, and then we have these boxed parentheses, and then inside you have information. You could have multiple different data types in here. For this particular list, we have strings or objects. You could have a list like the one that I put here as an example that had numbers. So there will be a list of integers. So this one is a list of strings, and then it's called a mutable data type because although you have apple, banana, and cherry, you could do things to it. You could remove apples, you could add banana, like you could multiply I mean, you could add more inputs inside those objects over there. And then once you've declared this variable and then you've assigned a list to it, this functionality that you can get access to. Like I said earlier on, that Python counts from 0 to n minus 1. We have 1, 2, 3. Our n is 3, so it's going to count all the way to 2. What do I mean by this? If you say, Python, can you print fruits and those box parentheses, and then you add a number 0 in there. This is 0, 1, 2. It's going to return apple, like it did over here when I ran it earlier on. If you say Python print fruits and then 3, it's going to return an error. It'll tell you that the list is out of range because you don't have 3 items. You have 3 items, but the indexing ends at 2. Right. We could do something called append, right? You see that we have apple, bananas, and cherries. We would like to add some oranges over there. We call fruits, which is our variable over there. And then we call this method called append. This is an example of an inbuilt Python function, by the way. So you put a full stop, and then, so sometimes I want to test if it's working over here. You just click the type of full stop, and then the first 2 letters of the method you want to apply, and then you hit tab, and then it's going to autocomplete with that inbuilt function that you have. So we want to append orange into our original list. So after we do this, and then I run print fruits, you can see we have apple, same order, banana, cherry, and then our new addition over there. So this is the first data structure list. We have another one called a tuple. So a tuple is immutable. Unlike our list, what you get is what you get. You can't remove a 4 and add a 5. And they always come in pairs. So for example, coordinates. Coordinates come with the longitude and the latitude. And if you print the 0, you're gonna get the 4 over there. This is very important that you need to keep in the back of your mind that you will always make mistakes if you forget that Python, when it counts, it will start indexing at 0. So if you want to print 4 and then you put in 1 over there, it's going to print to 5 because it's 0 and 1. That's how Python indexes. The more complicated data structure that you'll be looking at is a dictionary. So dictionary, just like a tuple, it stores data in pairs, but you can add more keys and values. So for example, we can store the information of a student. The student's name would be our key, and the name here would be the value. And then we put in this comma over here, and then we say the second key is age, and then the value is 21. And then we want to store that student's grade. So this is another key, and then this is the value A. You can see that we've got like different data types inside this dictionary. We have a string over here as a value. We have an integer here as a value as well. But now, how do you access this information inside the dictionary? You're going to print student name, so it knows that you want to pull the value assigned to this key. And you're going to get the name Alice. Or you could change this and say, I want to know the age inside the dictionary called student, and then you will get the age, which is 21 for Alice. Right, I'll demonstrate how we utilize dictionaries in our coding section. Right, now we also have sets. Sets are like the sets you know from your statistics. So we have 1, 2, 3, 4, 5, 6 inputs inside this set. Oh, by the way, this is how you differentiate, right? Your lists are going to have this solid parentheses. Your tuples are going to have 2 numbers, and then with this soft parentheses, this squiggly parentheses, that's your dictionary. And then they have keys and values. And then with the set, it's going to have the same squiggly parentheses, but just inputs just like you would use with the list. But now this is a set. So now the cool things that you can tell this set to do is I want to print the numbers inside the set that I have. It's printing 1, 2, 3, but then if you count the 1, 2, 3, 4, 5, 6 numbers inside this particular set, what Python is doing here is identifying that there's 1, and then 1 is already represented there, it's going to print 1. 2 is over here, there's another 2 where it's like, okay, 2 is already represented, it's printing a 2. So depending on what you want to achieve with that particular data structure, you will either use a dictionary, a list, or a set based on your desired output. All right. So now, under list and dictionary, you could tell that it's going to be a headache to be able to pass through this data, like to iterate and find values that you want. If, say, for example, we had 100 students inside this dictionary, like how on earth are you going to work through that? Python luckily has made developers that come up with a shorthand for us to be able to pass data inside either a list or a dictionary. It's called the list comprehension and also dictionary comprehension. So what does that mean? So this code that I had created earlier on, what I'm doing here, I'm creating a list. I want to store square numbers in there. I call it a squares list is equals to, and I use the formatting for a list. And you can see there's no information inside here. What I've just decided to do here is declare an empty list. This is a placeholder. I'm going to put information in it if it meets the conditions that I want. So now I tell Python, like, hey, Python, I want you to loop through numbers all from 0 all the way to 4. Remember, Python indexes at 0, and then it counts all the way to n-1. So if I want it to count all the way to 5, I'm going to say, I want you to count the numbers in the range up until 6. And what I want you to do is, for that x value in this range, I want to square it. Right? Remember earlier on I said that the asterisk there, you use it to multiply. So if we use 2 asterisks there, it is equivalent to you saying x to the power 2. Right? So now we want to append x to the power 2 inside our empty list, because remember I've declared the squares list over there as an empty list. Now I want to append, when it's at 0, square 0 and then add it in there. Right? It's going to say 0 squared, add it there. 0 squared is a 0. 1 squared, add it there is a 1. 2 squared, add it there is a 4. And then at the end, I want to print my list all the way to 4, right? And then this is what you get over here. So this code that I've written here is not, it's not easy to run when you have a range going all the way to 1,000. It's going to consume a lot of memory. The shorthand for you to do exactly what I did here, using shorthand, you could use what is called the list comprehension. Right? You say squares, they're declaring that list over there is equals to. So instead of leaving it empty here and then running operations in here, we're going to run the operation inside the list itself. So we say for all the items inside this range, x squared for x in that range, is going to keep squaring it, and then you go to the next, you square it, you go to the next. So this is a beautiful piece of code over here compared to what we have over there. I used to write my for loops like that. It took me a while to understand what this does, to try to make sense out of it. But eventually I managed to do it, and I don't think you will struggle to come up with the list comprehension, because you will just tell ChatGPT, I want to do 1, 2, 3. Can you give me a list comprehension? And then ChatGPT will understand exactly what is it that you want to do. In a similar fashion for a dictionary, right? We have this dictionary declared over here called grades. So we have Alice's grades is 85. We have Bob's grades is 90. We have Charlie's grade is 78. Remember, this is the key. This is our value. Key value, right? So we want to find out which student passed. And by student pass, we mean the ones that got over 80%. So we start by creating a past student dictionary, and then we run this shorthand code. And then this is the output that we get. We can see from this data that Alice has gotten a grade over 80%. She has passed. Bob has gotten a grade over 80%. He has passed. Charlie has gotten 70%, so he's 2 points shy of a pass. And then this is the output for our list comprehension. So you can imagine if you're running like a million rows of data, this is going to come in quite handy. Obviously, right now it's just 3 items, and it looks a bit silly. But once you start working with real world data, you understand that things can get out of hand very, very quick. You will be working with multiple sources of data, and then you'll be working with a lot of rows of information. So any advantage that you can take to get a processing speed up, you utilize. You start to refactor your code, or you write functions to do your processes, right? You put your code inside your function, and then it's easier and faster to run that way. All right, so that's it under data structures. Any questions or point of clarifications that we need, raise your hand or put your question in the chat before I move over to the second session. So silence is golden, so everybody's following along quite nicely. There we go. Go for it, Tshepo.
Yes, thank you. So I have a question on the list and dictionary comprehensions, where you have squares or underscore list is equals to, and you have your bracket. Yeah. So how did the let me maximize this. How did the X come about? Like, how comes X is the one representing the range that you want to work with?
Good question. I think that's a very good observation. Let me just add a cell over here. So I'm telling Python for the range from 0 to 6, I want you to consider all the numbers in that range to be accessed. What you can do, by the way, that's just an arbitrary choice. What you can do, what we normally do, we don't use an X, we use an I. It's just like the law. There's no logical reasoning for picking an I. There's no logical reason for picking an X, unless if in your code you have a for loop whereby you already assign X to something else, right? If you already assigned, like for this one, I've already assigned X is equals to that, and then let's say I wanted to repeat this code over here. Let's pretend that this one does something different than that one. I can't use an X as well, because now Python is going to still assume I'm referring to that X in this range. Then you could use a different number. You could use an I, you can use a Y, you can use a J. So the common ones that you will see when you're going through Python coding is that you'll see I and J.
Oh, okay.
Right. Yeah, so if I say J here, for J in this range, I want you to append this empty set with a squared number. Then I have to change the X. It no longer can be an X. I would have to say J squared, right? And remember how we represent squared in Python with 2 asterisks. So this code is going to give me exactly the same output as this one, even though I have an X over here and I have a J over here. That was a good question.
Yeah. Okay. Thank you. And my other question, where you have the K and then semicolon, I think. Oh, this one, yes, dictionary comprehension.
Yes.
Yeah. So I understand the first one where you have the grades and then you have the you have Alice, 85, Bob, and all of that. So, but when it comes to the second one where you have K, then colon V for K. So I don't get that. Sorry.
Yes. Good pick. Exactly the same. So the K and V. So this would be the key over there. The V is the value. Right. So K stands for V stands for value, Or what we could do, we can say, is Victoria,
Who get that?
I don't know.
so Victoria, can you mute?
But I demand the love.
Joy, can you please ask Victoria to mute? So as I was explaining, instead of saying K here for key, I could say A and grade. Since I've changed these, I have to change them here. Right, and then I have to say here name, and then grade here. So where is it gonna pick up the name and the grade? From grades items. Remember earlier on you asked me a question about inbuilt functions. Items over here would be an example of an inbuilt function, because what it does here, it looks at my dictionary and then it's going to pull the items, the name and the grade. So what this code is doing is it's going to store the name first and then grade, and then it's going to run this condition over here to say if V, but now we have to say grade. We can't say V anymore, right? We say if grade is greater than 80, we want you to return pass. So it's going to return the name of the person and their grade if they passed. Right. In a similar fashion, the letters, the variables that you start off here are purely arbitrary, but it's important for you to be able to look back at your code and realize, oh, this one, the K here refers to the key, and the V refers to the value. Right. Can I consider the question answered?
Yes. Thank you.
All right. I think Sago is happy. We have a hand from Precious. Precious, go for it. Precious, you can unmute and ask a question, or you can put it in the chat. You've got options. I would encourage you to unmute and ask the question. Okay, while Precious is sorting out the unmute button, Psycho, you have a follow-up question.
Yes, please. So for let's say the dictionary comprehension. So where we have the grades and then we are trying to sort the grades for these three people. So this necessarily have to be like in a data set like in a data set already that you upload onto your environment where you are doing the coding, or this one is just something that you have created and then you have an output for it.
All right. Again, good question. So this one, it's a data set. You've noticed that this is a data set that I have created to show you how a dictionary looks like and how you can run a reflected code to pull out inputs from your dictionary. So oftentimes when you're using APIs, it's called the JSON response. You're going to get data in this format, right? It's going to give you back names, and it's going to be like your key is going to be name, and then your value here is going to be a list of names, and then you would get grades here, and then inside the key grades, the response here it's going to be a list of grades. So you're going to have information inside information when you're querying data from APIs. So, and then you'll need to be able to either take this information, extract it, and then put it in like a data frame format, or you can just run the operations on data formatted this way in a dictionary.
All right, thank you.
Awesome. Precious, have you won with the unmute button? All right, I think Precious is still sorting it out. So now let's talk popular Python libraries, right? So these ones are the libraries that are going to be very relevant to you on your data science track. So what I would do is I would start installing all three. I think, yeah, most of them are going to be very standard. You don't need to install anything. The only thing that I would add here is maybe Keras. You don't need TensorFlow. Keras does whatever TensorFlow does. But you can add TensorFlow if you're feeling, yeah, if you're feeling adventurous, you can add TensorFlow. But Keras, it's a way easier way of building a deep learning models than with TensorFlow. So this duo over here, they come standard. Once we install Python, they will be automatically installed with you, right? If you using Jupyter notebooks, you already have access to Matplotlib. What I would do there is also add Seaborn, right? I would add Seaborn because I don't think this one is standard. This one is standard. This one is not standard. So these two would be for you to build your visualizations. And this one is going to help you with your numeric computations, of which you'll be doing quite a lot. And this one, basically, this is the holy grail for data analysis. And these ones would be your machine learning packages. Let me not confuse you with TensorFlow. I think we're good with those two. So the other one, this one has a lot of tree-based models. This one is deep learning models, but this is good enough for you to build like very good, robust models. If you want to experiment and build deep learning models which are not as accurate as tree-based models, you can install Keras, and then you'll have the same fun. So if you're going to be installing these packages, actually you need to run them line by line. Hey? You can't tell it to install multiple packages in one line, otherwise it's not going to work. So if you're going to be running it inside Jupyter notebooks, or notebooks rather, you need to start with this exclamation point over here. If you're going to be running it in Python, you don't need to do that. You just need to write pip install, and then the package name, and then you will get that installed to Anaconda prompt. If you're running it inside Jupyter notebooks, like I said, you would need to have that exclamation point over there for you to be able to install these packages. So once they're installed, now you're on your way to start manipulating data. So let's start with Pandas. It's still not, this thing is not, I'm not trying to take chances because CPU is not running. I'll try to use a GPU. Hopefully that connects because I really want to run the code now. So this is how you would call Pandas. So this is a lot of the stuff that you're going to see here. They're not going to make sense at first glance. There we go. Yes, we are running TPUs. So this is the function that I built earlier on to test whether a number is even or odd. It's saying check even odd is not defined. So if you get an error, and you're going to get a lot of errors, so this will often give you clues in how to solve your error. I know this is not on topic, but this one is saying the check even function is not defined. What that means is that I haven't run this cell. I ran this cell to define that function. Now I can test the function to say, let's check if 23 is odd or even. It should tell me that 23 is odd. Okay, I see what I needed to do is just to change to GPUs over there. Right. So now I can run this cell so that you can see I kept referring to data frames, and before you see what a data frame is, it sounds intimidating, but it's really not. It's just like a flat format, like your Excel spreadsheets. You have columns over there, and then you have the inputs under the columns. As a name, we have names over there. Score, we have the scores that they've gotten over there. This is how you would call your Pandas, your data manipulation package. You'll see that it's called I imported SPD. The reason I did this is because it's very standard in Python programming. So you need to get used to these shorthands, because if you're gonna go to Stack Overflow and look at other people's code, they're going to be coding in this format. If you don't code in this format and then you borrow code from somebody else, you're going to have issues with your code running, right? So now I'm putting Pandas as PD. Pandas stands for Pandas as shorthand. So this enables me to say, I have this data over here that looks like a dictionary, and you recognize dictionaries from the previous section. I want to convert this into a data frame. I want to make this a flat format file. I want to say, I want this to be the column name, and under this column name, I want to have these two, right? And underscores, I want the information to be below. So this is how you would convert this dictionary into a data frame. You call Pandas, and then this function called data frame. Let me just show you. Capital D, and then you see that method is over there, data frame, and then you just pass in your dictionary inside there, and then you run it. So once this is converted into a data frame, now you can apply data frame methods. The first one you can apply is head. Head just gives you the first 5 rows of that particular data frame, but we only have 2 entries, so it's going to give you all of the entries. What you can do as well, you can say, I want to check the bottom of the data frame. So you got like 1,000,000 rows, and you want to make sure that you have data all the way to the last one. You call tail over there, and it's just going to show you the bottom. If you had more than 10 entries, you would see the bottom over there. So now, since we've converted this into a data frame, there's a lot of exciting things we could do. Say, for example, you want to understand your summary statistics of your data. You would call this method called describe. This is a Python inbuilt function. I'm saying my data frame, can you describe it? And then it tells me count is 2. I have 2 entries. Mean is 88.5. So mean is an average in Python. So it means that the average of the numbers, so it's going to give you the rows that have numbers. The average there is 88.5. The standard deviation is 4.9. The minimum number in that score column is 85. The max is 92, and then we can confirm that here. So once you've converted into a data frame, there's a lot of exciting things you can do. Say you want to know the data types of your information. You click df.info. We call this method. It's going to give you the information on all of your data, right? It's telling you that you have 2 entries, 0 to 1. Remember, Python indexes from 0 to 1. So the first entry here is going to be a 0. So we see we have name. That's the column. It has 2 non-null entries, meaning there's inputs, there's no missing data. And the data type is an object. It's either a string or an object. And the second one is a score. We have 2 non-null entries. There's an int 64. This is an integer, right? Say now I wanted to just look at the first entry. The same way we've been doing, we use this square brackets. I say, give me the first entry by saying df0, and then it's going to print out key data error. Okay. Right, just give me the first name. Oh, actually, so yeah, your spelling is very important. Now you see the column I've given here is name with a capital N, but I wanted to call it with a small n. One way you could do to find out how your columns are written, you can call this method over here. Then what this will do is it will give you the names of your columns, and I want to print out name, the first name in the data set. So I'm gonna say df column name. I just want to see the first name in my data frame. Can you please return that for me? Then Python is going to give you Alice. Another way of doing this is you could say df dot name. So this is me calling the column name as a method, and then it's going to print it out. Say Alice is the first name in the data set. If I want to see the first score, maybe let me go for the second score. I can ask it to print the second score in the data set. It's 92, and then we can confirm The second score in the data set is 92. But remember, Python indexing, it starts with a 0, and then it counts upwards like that, right? So a lot of the things that you're going to be doing will revolve around NumPy. So I'm in Pandas, I would put an exclamation point on this one to say that this is the most important library for a data scientist. There's a lot that you could do if you have like a good enough data set, right? So now the second one is NumPy. So this is a numerical computation library. NumPy stands for numerical Python. So the same thing, import NumPy as NP. We use this shorthand to keep referring back to NumPy. So we know when we write code, we're referring to NumPy, right? So here I've created what is called an array. It's another data structure. So remember, we have lists, we have sets, we have dictionaries, we also have arrays. So the cool things that you can do with an array is I've created this list over here called 1, 2, 3, 4, 5. Now I've wrapped it with a NumPy array to say that force this list to be a NumPy array, right? So after Python does that, I'm just gonna comment this code out and try to print array so that you could see how an array, this is the array. So now what I want to do is we can run computations on the entire array, right? So this ARR, I want to multiply every entry inside this array with 2. But remember, our array is 1, 2, 3, 4. So what should come out is 2, 4, 6, 8, because I multiplied the entire thing with 2. So that's another neat thing that you could do with arrays. And then NumPy allows you to be able to do that. And I think this is the exciting part that you guys have been waiting for. So this is our visualizations library. It's called matplotlib. So instead of writing this thing over and over again, because you see, if you want to plot something, first of all, you would call it import matplotlib, and then we will import it as PLT as a shorthand. So now we've we've assigned 2 variables, X and Y, and we've put numbers in there. And the important thing that you need to note here is that the entries here have to be the same numbers as these entries if you're going to try to make a plot. So we have 4 entries in here for your X variable, and we also have 4 values for your Y variable. So what we will try to do is we'll try to plot 1, 2, 3, 4 on the X-axis, and then 10, 20, 25, 30 on the Y-axis. So you call matplotlib, and you say plt.plot, and then you put in your variables over here, X and Y. So now you provided a label for your X-axis. You say X label, I want it to be this string. The Y label, I want it to be this string. The title, I want it to be this one. And then once you're done with that, you say PLT show, because you want your graph to be printed inline. If you don't say PLT show, it's not going to show. And then you run your code. Now over here, you have the output of the plot that you just made here. 1, 2, 3, 4 over there, and then the 10, 20, 25, and 30 over there. All right. If I change the runtime to CPU, it doesn't run anymore. Anyways, so you could use exactly, you could do the same thing with Seaborn and then do your plots for it. This is just a simple graph that I plotted. And now I'm going to show you just an activity. Actually, before we go to the activity, I think this is a good point to take pause here and then clarify anything else I need to clarify under these packages. Questions, hands up. There you go, Psycho. You can unmute and ask a question.
Yeah, so for the graph that you have just plotted, when importing, why does it have the can you scroll? No, the commands, where you have the commands. Like on top, please. Can you show on top? Where you imported? Yes.
Oh, where imported here?
Yeah, exactly. So
All right.
give me a second. So, like for Pandas and for the other one that you imported previously, it was just import and then you imported. But for this one, I'm seeing dot something. Like must you add that there? Like it's just like import Pandas as PD, import NumPy as NP. But here I'm seeing import matplotlib dot pyplot. So
All right. Yes. So matplotlib has a host of functions. So the specific function that we want from matplotlib is pyplot. And pyplot is the one that enables us to plot here. So we are saying with this dot, from matplotlib, we want to import pyplot as PLT.
so if you don't put there, what happens? Is it going to give you a different result or something? Or it's not going to work?
If you don't add pyplot over there, so it's not gonna run because we didn't import pyplot. Pyplot is the one that enables us to run. You see, it says module matplotlib has no attribute plot. What that means is that the error we have is over here. We are trying to force matplotlib to plot, and matplotlib can't plot. It hosts a function that can plot, and that function is called pyplot.
Oh, okay.
And then after you import that pyplot, you are able to run your visualization.
Yes. Okay, thank you. So one last question. So when you were defining name, like on top where you have Alice, so I saw that there's nothing like print Alice or something. So
Yeah.
you just put DF and then bracket and then it's sorted.
Okay, when you have a name, oh, okay, yeah. So I think what you're asking is a notebook specific functionality. So if I say x is equals to 10, and I've assigned that to x, I can say print x, and I know x is assigned 10. So, oh, I made a mistake there. Right, spelling is very important. So it's gonna print out an x, but I can say x in here, and then it's gonna print out 10 as well. So you can only do that inside Jupyter notebooks.
Oh, okay. All right.
Yes.
Thank you.
All right. Any more questions? All right, I think we are happy to proceed. So this is an activity that ideally I would have loved for you to do by yourself before you can solve the solution. So I'm gonna ask you to be very honest with yourself. You look at Dennis, I saw your hand. I'm gonna give you a chance to speak now. I'm gonna ask you guys to on this hands-on activity, right? Before you look at the solution, you look at the instructions. Like you want to create a dictionary of students and student names and grades. I made a silly typo over there. You want to create a dictionary. I mean, a lot of silly typos actually. A dictionary of a student name and a grade, and then you're going to create a function to add more students to the dictionary. And then you're going to calculate the class average from the list of those students. And then you're going to plot the student name, grades, show class average, pass mark as constant lines. And then you're going to label your axis. While I'm fixing my embarrassing typos, I'm going to give Dennis a chance to ask his question. Go for it, Dennis.
All right. Thank you. I see similarities between Python and Excel, and in ways that, for example, Pandas is akin to cells and rows in Excel. So I want to know, in what way does NumPy relate to Excel? Because I think when I started learning Python, it was one aspect that I saw, and that really helped me in actually understanding how Python operates. So I'd want to know, how does NumPy, relate to Excel? Thank you.
Okay, so with NumPy, if you want to do like your advanced statistical analysis, you would get a lot of functionality from it. But I think just using Pandas for your data manipulations and building models, building graphs, you can get away with not even touching NumPy until it comes to a point where you want to use some analysis of variance, like, those are advanced statistical tests, then you will need either SciPy or NumPy. But I think you can get away with just working with Pandas. And like you said, because it's very similar to Excel, it is very intuitive as well. Excuse me. Are you happy, Dennis, with that response?
Yes. All right, thank you.
All right, thanks, Dennis. So yeah, guys. So this is the hands-on activity. We start off by creating our dictionary. We say we declare this variable called student, and then we assign it an empty dictionary, and inside that dictionary we add keys and values of 3 students. And then we go ahead and create a function that would help us to add more information to the dictionary that we already have. Remember, I told you that when you're creating a function, you start by saying def, and then the name of your function. So the name can be shorthand for something that your function does to make it memorable for you as well. Because you can write code today, and then you come back tomorrow, you forgot what you did, and you remember that, okay, I need to add more stuff to the code that I built yesterday. So this is going to be very descriptive for you. And another interesting thing that I actually forgot to mention that I've just noticed right now, I'm just going to copy this function here and come on top, add a cell, and say this. This is one important thing that I should have pointed out under the syntax. That when you build a function, when you declare variables, it doesn't matter what it is, right? You start by saying def, and this is the name of my function. I want to add student, and then I want to add the name and the grade of that particular student, and I want to append that information inside my my dictionary, which is called student. I want to take the name and the grade and append. This is just me declaring the function. I haven't done anything yet. Then I try to run it. And then Python is going to tell me that there's an error in my code. It expected a parentheses over there. This is a syntax error. So oftentimes when you get errors, it's going to tell you that, hey, this is a syntax error or least out of range error and something like that. And then you understand that you either typed something incorrectly, that Python wasn't expecting that particular format. And then you need to fix that. So I removed that underscore that was here initially because when I was writing this function, to me, it just comes naturally. I add an underscore. But with Python, it does not interpret spaces very well, right? It's going to always keep spitting errors. So you need, if you're going to use 3 words, put underscores in between the words, and then Python would know this is one variable, right? So the add student now is going to be a function called add student. Similar thing when you're declaring a variable, right? If you say student and you say name is equals to Dennis. Sorry for picking on you, Dennis. Student. Right. If you say student is equals to Dennis, it's going to spit out an error because it wants it's interpreting this as 2 different things. But now you need to add an underscore to tell it this variable is one variable. Now our student is equals to Dennis. All right, let's go back to our hands-on activity. So after you've created that function, so this function is going to add this key. It's going to look at the student and the grade and then append it to that one. And then we could pull out our values from the student's dictionary. And then we want all the values and then we divide them by LEN students. Kauribi has raised his hand. Go for it. I hope I pronounced your name correctly there. Kauribi, you can unmute and ask a question. Are you winning with the unmute button there, sir? So Kauribi, if you can't manage to unmute, what I'll suggest.
Thank you very much. My name is Zakaria from Ghana.
Okay, go for it, man. Hey, you can ask your question.
Sorry, my network is a bit unstable here. Please, can you hear me?
I can hear you clearly now.
Okay, thank you very much. My name is Zakaria from Ghana. I wanted to know, with defining the functions, like let's say, for instance, df calculate average and stuff. What happens if you don't bring the return function?
All right. Yeah, that's a good question. So let me add this. So what I'm gonna do is I'm declaring that function. I'm gonna say function name, and then I'm gonna say it's called an argument next, but I think the argument is taken in Python. I'm just gonna say arguments over there, and then here I'm gonna say do something. And then I'm gonna say return something. Right. So this is the structure of functions in Python. You start with your function name. The argument is okay, and I need to say do something with argument over here, and then return something. Right. So you're gonna have three things that are three key ingredients to your function: declaring a function name, declaring an argument, and the output that you want. Right. So now I'm going to make an example. I want to say df function number. Right. What do I want to do with the number? Because the number is my argument. I want my function to do something to the number. I'm going to say result is equals to, we need to use our argument. Okay, multiplied by 2, right? So I want to multiply this number by 2. Actually, let me not multiply the number by 2, but rather use a square root, and this will also give me an opportunity to introduce this particular notation here. So if you raise to the power 0.5, it's gonna square root whatever number you provide. So yeah, so and then here we want let's do this to demonstrate your question. So I said def function name. Let me just call it what it does. Right. So this is a square root. I'm just gonna add the s because the square root might be a defined function in Python, and I don't want to override it. So our function name is square root. It squares the number we provide. Right. And then I say enter, and that's fine. We get no errors. So now let's give it a. I want to square 100, and the square root of 100 is supposed to give me 10. Let's see if it's going to give me 10. So the function ran successfully. It raised 10 to the power 0.5, which is a square root, but there's no result. Why is that? Because I didn't instruct Python to return this result that it did over here. So I've assigned result variable. So now my number is going to be a square root, and then it's going to return it over here. Let me run it now. You get no errors. If I run this again, it's going to give me a 10. Remember earlier on I spoke about refactoring code and making sure that you write as little code as possible. What you could do as well is you could actually remove this variable, you remove result, you remove that stuff, and then you say, I want Python to return that instead of declaring a variable and then assigning it the computation, and then you run this, and then you run the square root again, and it's going to give you 10 as well. Do you see now the importance of having a return statement? Okay, we have another hand up. You can go for it.
Oh, sorry. We just realized you are running the lines of codes in different cells. It's just outside the what you are doing. But can you just explain? I have been using, if I am doing something like a function, I do it in the same cell. Is there any harm if you do it outside the cells, like
No.
different cells?
No.
It
Let me
doesn't
show you.
conflict. It doesn't.
Yes, the important part is that you declare it correctly over there, and you run it, and then you test it out. Okay. Indentation. I told you about indentation. So because my indentation was there, Python thinks it's still under the function. So you needed to take it all the way to the start.
Oh,
Yes, but you should run it, and then nothing should happen. You can run it in the same cell.
oh, I have been
Okay.
doing it like that way in the
Yeah.
same cell, in same cell. There's no
So
harm
like
if
I
you
said,
run. It's,
it's actually smarter to do it that way, to have as few cells as possible, to refactor your code and compact it as possible.
oh, okay.
Yeah. So you're doing it
Thank you.
correctly. Awesome. Dennis, your hand is up. Go for it.
All right. So initially I thought the DEF and the DF were actually used or actually meant the same thing. So in this case, with what you are trying to show, it means you only use the DEF when you are trying to actually use a function, right?
Correct. Yeah. So my apologies there if I confused any of you. That's a good pick, by the way, Dennis. So this DF, this is shorthand for data frame. I told you use a lot of shorthands, but ideally what I could have done here, so I could say maybe students, right? To make it less confusing. So I know these are students and their scores. I could say student score, right? I've assigned student score to this dictionary. I want to convert this dictionary into a data frame. So what do? I can just say that, rename it here and say my student score is equals to, I'm going to override this one, but I want this one to be converted into a data frame. So I need to wrap it inside that data frame method over there. And then I'm just going to say student score over there. I can remove the tail because you only have 2 entries in this data set in any case. But in order to avoid confusing, I could have done it this way. Or maybe let me just say data here to make it less confusing, because I realize now I just renamed everything to the same variable, which is also confusing, right? So I took my data here, which is a dictionary, and then I converted it into a data frame by wrapping it inside the data frame method from Pandas, this data inside here. Now I've assigned my student score to be this data frame, and then this is the student score. So now you can go ahead and actually do exactly some of the same things I've been doing here with it. You could say, describe my student score. It's going to give you a statistical summary over there. Give me the information of my student score. It's going to do exactly the same thing over there. Right, and then I want the second score in my student score data frame. It's going to give you an empty 2 over there. So DF is just shorthand. DEF is a Python inbuilt argument that you need to do. Correct. Saiko, I see your hand is up again. Go for it.
Yeah, so is it that if you don't put the data frame, is it because you want it to appear in tabular format? That's why you run the the data frame command with it.
Yeah, exactly. So you're correct with that one. So it's kind of hard to demonstrate the value add here because I only have two columns. But what I could do is let me add another key over here and say gender, and then under that gender, I want to add, let's say the first one is Alice. So Alice is our female student. Then I'm gonna just to demonstrate also not to confuse you. Rather, let me just stick to using double quotations like I've instructed you guys to, because it's actually a good practice to use double quotations. Female, and our second student Bob is male. Right, so I've added gender. So this is another key, and these are the values under this key. And then if I run this column, we should have three columns now. Now we have Alice, we have her score, we have a gender, we have Bob, we have a score, we have a gender. Right.
Right.
So the reason you are running your data inside this data frame wrapper from Pandas is you want the output to be in this tabular format. Once it is in this tabular format, you can actually do a lot of cool things. And for this one, you can only see summary statistics for score because it has picked up that score is actually integers. Right. If we add, let me add another column here called age. So I'm just gonna pick ages 23 for Alice and maybe 25 for Bob, and then I run that, and now we have the fourth column, age Bob. If we run this describe method, it's gonna return both score and age. Right, so now we can see we have two entries. The average is 24, 23 and 25. 24 is in the middle. The lowest one is 23, the highest one is 25. So wherever you have integers, you're going to keep adding up here, and then you'll get summary statistics for all of your integer columns. Happiness? Awesome.
So last one, please. Maybe I'm asking too many questions already. So
I think we still have 12 minutes, so you can ask a question.
Yes, under the hands-on where you add student's name. Can you please scroll to
the
where you are
name.
solving the hands-on? Yeah, where you are solving the hands-on, the practical, like the exercise down.
Okay.
Yes, that first one. Add student. So we want to add like another student, like the name and then the grade. So after the column now, I'm seeing instead of just name, you're saying student's name. But when it comes to the grade, there's nothing like student's grade.
Okay, so when you run this function, you will supply the name like this format. It's going to be a string, and the grade is going to be an integer. So the way we did it here, we said that for students, which is this dictionary, our key is name, the one you'll be supplying over here. And our value is grade, the one you'll be supplying over here. So if you notice, the question that was asked earlier on is that, do you need a return statement in your function? So for this one, the way we are implementing here, you don't need to have what you call a return statement. You'll see we'll force the dictionary to accept the name that you supply and the grade that you supply. And then it's going to add an additional entry over there. So I'm not sure if you're following this.
Yeah, I'm following. Just that I'm seeing so after the column now, so I'm seeing, oh, okay, so the student
Yeah.
So it's the name in bracket for me that I don't know why, like the students and the name, how that comes about. the students
Right.
and then the name in bracket. Yeah.
Remember, you have to supply two entries. If you're going to add information to the dictionary, you need a key and a value. Our key is student, and key is David, and David's grade. So the format that we build the function over here, it takes in two arguments, the name and the grade. You could see the way we are implementing it over here. So running this one, it's just going to take student as the dictionary student and add grade. I think maybe one way to demonstrate this would be to run the code so that you can see. All right, so we've declared this dictionary. Let me just call it here so that you can see. See the output. So this is our dictionary, right? 3 students, 3 grades. And now we want to build a function whereby we could add more people there, and we don't have to come in and type every time the name and the grade, the name and the grade. We just want a code that's going to keep doing it for us over and over. So we define this code. So whoever adding people here, they're going to need to submit the name as a string, grade as an integer. And then we come here, right? And now we want to add that student. We say add student. Now let me call the dictionary so that you can see if our dictionary has changed. You see now David and 88 is there. This one doesn't have David and 88, but we've added David and 88 over here. I can even add you, because maybe you're 100 student. So let's give you 100.
Yeah, I see that. I actually get that. It's like why the student is in bracket over there and then the grade is not, like the name is in bracket, but then the grade is not in bracket. For me, I'm seeing this name and the grade after the column to
Yes.
represent the name and grade in the bracket.
Right. So what you're pointing to is you are inputting 2 different data types over here, a string and an integer. But remember that our
Right.
dictionary is built that way. We're taking the string, which is a name, the integer, which is a grade. So if you're going to add more information, you're going to need to add the information in which the dictionary is built according string and integer. Right.
Yeah,
We've
so
had another time. Oh, you're still not happy?
no, it's fine. It's okay. All right.
Okay, let's give another student a chance to ask a question. Remscout, you have had your hand up for a while now. Can you go ahead and ask the question?
Oh, sorry. On the same line of dictionary declaration, can you declare an empty dictionary? Then you just add the names afterward, like with the function. The function you have declared, you are defined the user defined function.
Yeah, you're right. You can declare an empty dictionary. You can declare an empty dictionary like that, and then actually let me try to. I want to try and reformat this code to refer to this empty dictionary. Let me print it here so that you can also see that it's an empty dictionary. So it's just returns an empty set. So now I want to add, I've created this function that would add the name and the grade. Let me just try to add our most vocal student. And then let's check this empty dictionary if it has the vocal student in it. See?
Wow. Okay.
So in a similar fashion with an empty list, you could declare an empty dictionary, and then you could use the same function to keep adding information. The beauty of having this function is You could do a for loop, right? You could say you had a lot of pairs, let's say names is equals to, let me say David, and then, but this one is not going to work because this is a list. It needs the same data data inputs. And you say for name, in names, right? And then you say you run this function that we've built. Say copy for name in names, and also for grade in grades. You would obviously have to define names. You have a list of students, their names, and another list that has grades. Then you look through these two grades, these two lists, and then you add student, but instead of the actual name, you just pass in the variable that you've defined over here. And then instead of grades, you do this. And then it could populate your dictionary quite faster than you would do if you were going to do it manually. So that's why we have these for loops. So this is basically the culmination of this lesson today, is to show you very different ways in which you can interact with the data, input data, and then make sure that you run your code faster, if you will. So we have 3 minutes. I just want to run through this one. You'll have the opportunity to run through the code. I'm just going to ask you to apply your integrity. Just look at the instructions and then try to build that before you actually get to the solution, because that's what the solution should look like. Once you've done, you would see the names of the student inside the dictionary over here, their grades, and then this is the pass mark, which is a 50%. And then we look at average if you want to pick out your above average students, Bob and David. This is the part that I told you about the real world applications. So I'm just going to quickly run through this one to respect time. On a day-to-day basis, you would query data from a database. You could use Python to query data from a database using SQL language. So you write SQL language inside Python. You will start by connecting to whatever database you have, and then you would create these columns, and then you would query that information, right? So now the second part of this is assuming that you've queried data from your database. You have your outputs. So Pandas does come with preloaded data sets. One is called Iris. So it's basically data that measures leaf sizes of particular species of trees, the Setosa, Versicolor, Virginica. And then you could use this data to train yourself to build machine learning models. You could run this code actually. Let me just quickly do that so that you can see. So I imported all the packages I need. And this is the SAK-learn model that I told you about, that it does a lot of tree-based models. You build very decent models with this package. You run it Keras, and then you would just pull this data from Pandas, and then here's the data frame of that particular data. And then from there, you could build what is called a pair plot. So a pair plot just gives you the indication of whether your data has a good separation. So if you look at this value here, the sample length, we have 3 different colors. The blue color there is a Setosa species. The orange color is the versicolor species, and then the green one is a Virginica. So we have got like a clustering over there, clustering over there, clustering over there, a bit of an overlap there, but generally we have a good separable data set that we could build a machine learning model that would help us classify species based on the data. So now I would start to train a model. There's a lot of things that I've done here, but what you need to know is this code, what I'm using is I'm taking this data set, I'm splitting it into my training data and the testing data. I'm going to use 20% of this data to test my models. I'm going to train it on 80%, meaning I set aside 20% of the observations that I'll be using later on to test the accuracy of my model. I train the model, and then I build the model, and then I get the accuracy of 96. The important thing is to get your your validation, you could see the model as predicted Setosa, well, it's actually Setosa over there. And then this is where I do my model validations. This is a very important metrics to be able to know that your model is not overfitting, meaning that it is taking shortcuts to make your predictions. You can incorporate matplotlibs to create this visualizations to look at the number. I was supposed to predict 10 Satosas, I got 10 correct. I was supposed to predict 10 versicle, I got 9 correct, and I incorrectly classified one as a Virginica. The same thing with Virginica, we had 10 observations and I classified 9 correctly, and then 1 incorrectly as a versicolor when it was a Virginica. So these are the things that you could build in the real world that actually I've built in the real world. The second one is a Flask web app. You could use Python to build web applications. I've already given you the code over here. You run that code. What it does is it's going to build a web app for you whereby you can open it up and then it's going to prompt you for a student number. You already have student numbers in this data set. Here, you punch in the student number. It's going to go through the data set and check the name and the grades of that particular student, and it's going to return that information for you over here. We are a minute over. If there's any questions before I hand over back to Joy, I'll take them now.
Kindly scroll to the hands-on assignment. Let me take a snapshot of it. Thank you.
Can I scroll to the? Zachariah, I missed that. Should I scroll to the what?
The hands-on. The hands-on.
I think they said they will share the Google Colab
Yes,
for us to access.
You will get the code. You'll get everything. You happy, Zachariah? I think we are happy. Joy?
I mean the one we are creating a function for students' name and grades.
Oh, okay. That's why.
Yes, please. I got it. Thank you.
Cool. Right, Joy, I'm gonna hand over back to you. I want to thank you for the opportunity and also thank the participation that we got from the students. I am more than willing to take your questions even outside here to help you on your learning journey.
Thank you so much, Kenneth. I must say, I would say in my heart that this session was like a dream come true. Don't mind me, right? This session was really awesome. I really loved the engagement, the interaction. I really like the fact that everybody was asking questions. So I must say thank you for this opportunity. Thank you for agreeing to be a mentor and taking this session with us. We really appreciate, and yes, we really appreciate it, right? And we definitely want to have more sessions with you. So thank you very much, everyone, for joining. We really appreciate it. And yes, Kenneth has already shared the. I'm so sorry for the noise in the background. Yeah, so Kenneth has also shared the link to the Google Colab so everybody can have access to it. So I think that brings us to the end of today's session. Thank you very much, everybody. So I think we can begin to leave the call right now. Thank you very much, Kenneth. Thank you very much, everybody. So I think we can just begin to leave the call. Why I cannot end the call for everybody because my device is, I can't do that to my device at the moment. But I really want to say thank you very much, Kenneth. Thank you so much for your time. We really appreciate it. I don't know, before everyone starts leaving, I don't know if you have like anything to say to the people. I don't know if you got that.
All right, now I'm
Yeah,
happy,
I
Joy.
was saying.
Yeah, I was
All
saying
right.
I'm very joyful. I've already shared the link in the chat. Everybody download the link and then just go to the hands-on activity. Just look at the instructions and then try to build it out, and then you look at the solutions. Thanks everybody for joining.
Thank you very much, Kenneth. Um, yeah. So that brings us to the end of this session. So bye, guys. Let's all enjoy the rest of our weekend. All right.